Good morning, my name is Samantha Riles from Sugar Research Australia, and I'd like to welcome you to our first Milling Regional Research Seminar for 2020. Today we have two speakers, Dr. Ehsan Arzaghi from Queensland University of Technology will be presenting on reducing surging in shredders. Dr. Geoff Kent from Queensland University of Technology will be presenting on eliminating roll arcing. Please note that today's webinar is being recorded and a copy of it and the slides will be sent to all registrants. Throughout the presentation, all attendees will be on mute. If you are having any technology issues, please send a message in the chat box, which is located on the menu bar of your webinar screen. If you experience any issues in hearing the sound coming from your computer, please feel free to join by phone. I have put this number in the chat box. I will be assisting as a co-host to ensure that all runs smoothly. We encourage you to take an active part in today's webinar by asking questions. As this webinar is in listen-only mode, you can do this at any time throughout the webinar by typing your question into the Q&A button on the menu bar. At the end of each presentation, there will be an opportunity for Ehsan and Geoff to answer those questions. If it is easier for you to ask your question verbally than to type in the Q&A, please use the hand up button and I will then be able to unmute your microphone. As I moderate the questions, I will let you know who is asking the question. If you prefer to stay anonymous, there is a box you can check to remain anonymous. Our attendees from today include staff from these milling companies: Wilmar, Tully, Mackay, Sunshine Sugar, MSF and Bundaberg. I'd now like to hand over to our first presenter for today, Ehsan.
Thank you, Sam, and good morning, everyone. Thanks for attending my presentation. I'll start sharing my screen for you to be able to see the presentation slides. Well, today I'm going to talk about a project that is currently being conducted in collaboration with Peter Chauhan and other people at MSF Sugar and Tableland Mill. The project is about reducing surging in shredders at sugar mills. Well, this project was initiated because of a specific problem at Tableland Mill, which is surging in the shredders. Surging in shredder requires the mill to adjust the grid of the shredder to a wider distance, and that will in turn reduce the level of cane preparation to what we desire to have. Which is causing a loss for every mill. And basically, we would expect this problem to be more prevalent across industry because the industry is trying to be more energy efficient by using electric motors. And electric motors are less forgiving when it comes to surging. Surging will significantly impact electric motors by reducing their lifespan, and it will turn into huge consequences for every mill. So our aim is to basically improve feeding consistency of shredders using feeder rolls. To achieve that aim, we've set few objectives, which are basically investigating current shredder capacity and comparison of industry standards for tableland peak crush rates, also modifying the setting and design of feeder rolls at tableland mill, developing theory of operation of shredder feeder rolls for us to be able to develop guidelines for design and operation of shredder feeder rolls. And we would like that guidelines to be applicable to other mills across sugar mill industry. Peter Chauhan at Tableland has previously designed and built a model of the actual feeder roll, which is scaled down to 3.4 times smaller than the actual device. And the feeder roll has a 370 millimeter length. The feeder rolls are run by a variable speed drive, which is able to provide a maximum rotational speed of 6 rev per minute on the feeder rolls. As you can see in the picture here, the chute volume is around 50 liters. And with the current feeder rolls on the model, there are 7 rings of teeth, each ring having 16 teeth. We are planning to use this equipment for our experiment, but we would certainly need, and we are doing it at the moment, to modify it to be able to make variations in the design of the feeder roll. Since the feeder roll is scaled down, we try to investigate how we can reflect on actual billet sizes that are being prepared before milling, and to be able to control the material size in terms of billet diameter and billet length. We have concluded to use timber dowels that will allow us to particularly select diameters and lengths that we want to try to run tests with. However, there is an issue with using timber dowels, and that's a significantly lower density in comparison to actual cane billets. And to eradicate that issue, we try to see if we are able to soak dowels in water and see if we can increase the density. As you can see in this plot, I have tried to soak different dowel lengths, different samples of dowels in water for a certain amount of time, which has been done on an 8 millimeter diameter dowel for 24 hours of submerging them in water. And as you can see, we managed to get 50% increase in average in the density of the dowels. However, after 1.5 hours of taking out the dowels, the density again started to decrease. So that's why it is important for our experiment to make sure that the dowels are constantly brought back into submergence, and we don't create extra uncertainty throughout the experiment. To design the experiment, it was important for us to reflect on the actual design and operation of feeder rolls across Australian sugar mills. That's why we conducted a survey about different designs of feeder rolls and how they operate their equipment. 11 mills responded to our survey, and those are the mills that actually have feeder rolls on their shredder. And we have finalized the design of our experiment based on the responses we got. And as you can see in this table, we are going to use a split plot to run the experiment. One of the parameters that are important for us is dowel size and and to have a good variation of sizes, we have planned to use 6mm, 8mm, and 10mm diameter dowels. And we are going to change the length of dowels at each treatment from 32mm to 50mm. The other parameter that we are going to change is feeder roll speed. And we're considering a good variation, which is 3 rev per minute and also 6 rev per minute. The plan is for us to test the setting of the feeder rolls, and the consideration is to have 0 setting, which is basically from tip to tip of each ring, and we are going to vary this by the diameter of the dowels that we're going to use, and we are also planning to consider meshing the rings, actually bringing them closer than 0 setting together. However, this needs to be checked with the few tests that we're going to run at the beginning, whether that is going to cause choking or it enables us to run the test. The other parameters are basically the number of the teeth on each ring and how we are going to configure them in terms of offsetting. The plan is to have a gradual offset along the feeder roll for the 8 and 16 teeth configuration. And also we have another configuration which is having 8 teeth per ring, and on each second ring we are going to offset the ring by half a tooth. And the last parameter is the pitch, which is basically how many numbers of ring we are going to put on the feeder roll. And 5 and 7 rings are what we're going to consider. In terms of measurement and data acquisition, the VSD that runs the feeder rolls is able to output speed and current. And we are going to use these 2 parameters to basically understand how much power consumption we have. And as you can see in the figure, and I'm showing to you now, we are using a platform scale under the chute, and that enables us to basically measure feeding rate and see how consistent feeder rolls are feeding dowels. We're also going to install 2 GoPro cameras, one just across the center line of the feeder rolls and one a little bit higher up around the chute height, to be able to see how feeding is actually done throughout the test. We have set the model at Tableland a couple of weeks ago and did some preliminary test trials, but we actually used wood chips because we were not supplied with the dowels at that moment. We recorded the feeder roll speed and the current output from the VSD, and in a few seconds I'm going to show you a couple of trials that we have done. And this particular test was for the maximum speed of feeder roll, which was 6 rev per minute. I'm going to start the video now. The aim for this trial was basically to understand if we are able to acquire the data that we want, and also the variations and the changes in speed or current. And as you can see in the current, in the bottom plot, we have managed to capture the changes in amps throughout the test. And that is basically what we want to see for being able to measure and power consumption and changes in that parameter. The second one that we did, and it turned out to be very interesting, was with half of the speed of the previous test, which was 3 rev per minute. I'm going to start the video. So as you see, the feed rolls choked. We are yet unsure if it was because of the strange dimensions and texture of wood chips that we used, or actually the motors basically jammed because of lower speed and not enough torque. And if I compare it to the previous slide, the output current was around 1.5, the average was around 1.5 amps, but when we had the choking, the amps increased from 1.5 to 3, and that shows that basically we are able to see the changes and understand where the problem starts. The last video that I'm going to show you is basically when we try to understand what is going to happen if we change the rotation direction of the feed rolls. And I'll let you to see what is happening. You can see that there is a significant damping effect when we try to reverse the direction of feed roll rotation, but as long as the parameter observation goes, the test has been very nice on amps and speed of feed rolls. So the future steps are basically to complete the experiment, reflecting on the parameters that we are planning to change. Once we complete the experiment, we will statistically analyze the results to see the significant effects of each parameter on power consumption and feeding rate. The next step will be to develop guidelines for feeder roll design and operation that will be performed based on the theories that are available for 2-roll mill design and operation from Dr. Kent's thesis. After that, we are going to implement the changes based on the guidelines we've developed at Tableland Shredder by comparing power consumption on the shredder before and after the changes are applied. We are going to make judgments of how effective the guidelines are and make necessary recommendations. And we are hoping that the result of this study will help other mills with feeder rolls to improve their operation and benefit from the results. I would also like to acknowledge the contribution and helps that we have received from Mr. Michael Maggs, John Muller, and Jason Cooper from Tableland Mill, other staff of MSF Sugar and the management of Tableland Mill, Mr. Wayne Cislovsky from Wilmar that has contributed to this project through discussions that we had with him. And also, I would like to acknowledge the financial support that we received from SRA, and particularly the sugar milling R&D capability building project that enabled us to join Australian sugar mill research community and contribute as much as I can. I would like to thank you for your time to attend this presentation, and now we would appreciate any questions or comments.
Hi, so if anybody wants to ask a question, Before we move on to our next presenter, I'll just give you a couple of moments to type those into the Q&A. Okay, so we may move on now. However, if you do have a question, please add it into Q&A and we can come back to it at the end. So now we'd like to move on to our second presenter for today, Geoff Kent. Thanks, Geoff.
Yeah, thanks, Sam, and thanks, Ehsan. I'll just share my screen. Okay, so thanks again, everyone, for joining us this morning. It's an unusual way for us to be doing our regional research seminars, but at least it gives us a chance to talk about the research that we've been doing in the last year. So this presentation is a new project called Eliminating Roll Arcing that we actually only started 4 weeks ago today. So before I move on, I'll just talk about or introduce the rest of the team. You've already met Ehsan, who's just given the previous presentation. One of my other colleagues at QUT, Rui Torres de Oliveira. Rui's a business analytics guru, and he's been helping us out with some cost analysis. Steve McLaughlin from Mackay Sugar, Nazmul Alam from CSIRO, and Tini Van Blert from Wilmar. So I guess with a title like Eliminating Roll Arcing, one of the things that we're targeting in this project is the fact that there are significant health, safety and environmental risks associated with the roll arcing processes that are used in every factory, and also significant costs associated with roll maintenance. What we're trying to do, as the title suggests, is to get to the stage of actually eliminating roll arcing through the use of long life roll coatings, a topic that we've been working our way towards for quite a few years. The two technologies that we have available that have been worked on since the 1990s. Firstly, the tungsten carbide chips for putting a rough and durable coating on the groove tips has been around since the 1990s. And in our previous project that finished a couple of years ago, we looked at the idea of using laser cladding to put a durable coating on the flanks of roll grooves. And so this project, the objective was to have a go at both different techniques and to see whether or both of these technologies can give us a better all-round result in terms of the ultimate costs of maintaining the roll surface. So if we look at the project objectives, we're looking for the coating technology, as I just said, that minimises the roll shell maintenance costs. And I'm using the word costs in a very general sense because I include the health, safety and environmental risk costs as well as the easily defined direct costs. From the previous work we've done, one of the, I guess, biggest limitations is not so much on tungsten carbide because we've done that before, but determining service life. And when you're looking at the economics of spending additional money up front to prepare the surface for the season, you need to get a certain life out of that surface to be able to justify that cost. And the laser cladding is something we have not yet had a chance to look at in service. So as I said, this project's only started 4 weeks ago, and what we have planned for this year, and we've started doing already, is the first 2 stages of the work. The first stage is a baseline evaluation. So it's really about us trying to gain a good understanding of the true costs of the current roll arcing process and the other roll shell maintenance costs that are currently sustained. The second part of this project is associated with the preparation of a roll to go into service at Racecourse Mill this year. So firstly, just talking about the baseline evaluation, this work is getting close to completion. We did start late last year in terms of providing a survey to go to each of the milling companies to seek out the actual costs of roll shell maintenance. And we did get responses from six companies, covering a total of 15 mills, which was nice to see. We followed that up last week with some interviews at Racecourse and Pioneer Mills to try and quantify the other costs. So this is where we're trying to get down into the difficult territory of trying to assess what the real costs are associated with health, safety and environment. And to do that, we spoke to a number of roll arcers themselves. We spoke to other people who work around the milling station, like roving drivers, console operators, shift supervisors. And we also talked to the managers, engineering managers in particular, who have the task of allocating staff to roll arcing and talking to them about what those roll arcing people would be doing if they didn't have to arc the rolls. So there were a lot of dimensions to this evaluation. I haven't got any results to show yet. In fact, Ehsan and Rui, who have been working on the evaluation, I'm expecting a report from them tomorrow, since we have a milestone due next week, and we'll then have some proper data to present. Now, moving on to the roll preparation task, we are planning to coat the top roll of Racecourse number 5 top roll. Number 5 mill at Racecourse is a 6-foot mill, doing 500 tonnes an hour. So it's a reasonably significant duty. The experiment itself, and this is a plan that got updated yesterday. So I'm actually at Racecourse Mill at the moment, and we've been working since the beginning of last week, trying to get this roll preparation work underway. The plan at the moment is to look at 3 cladding materials on the flanks of grooves, and also look at the case of not putting any cladding on the sides of the grooves. We are looking at, in terms of the tungsten carbide, we're going to put around on the tips of the grooves. We're looking at either 3, 5 or 7 runs of tungsten. So with 3, what we're talking about is one run around the tips of the grooves and 1 on either side, going up to 7, which is one run on the tip and 3 runs on either side. So when you're looking at 4 different cladding treatments, 3 cladding plus no cladding, and 3 different treatments of tungsten carbide, 4 times 3 is 12. So we've got 12 experimental grooves that we'll be assessing this year on this one roller. And the way we're arranging things is to use every second groove tip as a test groove, and also the flanks on either side of that test groove are going to be coated or clad with the appropriate treatment. And the 12 grooves, or I guess essentially the 24 grooves that we're talking about here, the 24 grooves in the middle of the roll. So the grooves at the end of the roll won't be part of the experiment. But we are going to have some tungsten carbide on all of them as well to make sure that the overall diameter loss across the roll, across the season, remains fairly similar. And we'll be, in terms of determining which groove has which treatments, it's simply a random process to determine which order they're going to be in, to try and eliminate any sort of bias we might have due to preferential wear on any side of the grooves. Okay, we were going along very nicely until Monday this week, and the coronavirus eventually caught up with us, unfortunately. We were within a day or two of being ready to start laser cladding, when unfortunately the CSIRO staff we had with us up from Melbourne were recalled by CSIRO due to the various risks associated with the virus. So that's caused a change in plans that we're currently seeking approval through with SRA. But essentially what we have planned is to replace the laser cladding on the sides of the grooves with cladding using MIG welding, which is a process that SWP have been working on in the last couple of years. It was a process that we didn't think was suitable for the task when we designed this project originally, but we did plan up until yesterday to have one MIG welding coating to compare against the laser cladding, but now our plan is to use MIG welding for all of the treatments. So we are also planning to do some comparisons to other roll shell treatments. We have a number of different cases to consider. At Racecourse, we have, I guess, a convenience of having 3 6-foot top roll or 6-foot mills, one after the other in the milling train, and they are all different. So Racecourse number 3 top roll this year will be, or the shell is from Bundaberg Walker's Material A, grey cast iron Material A. It's going to be conventionally arced. Racecourse number 4 top roll is Bundaberg Walker's Material B, also going to be arced. And we are also going to do a comparison with Plain Creek's number 5 top roll. So Plain Creek being the mill adjacent to Racecourse, fairly similar rate, and I guess the bigger difference is that it's a 7-foot mill rather than a 6-foot mill. But one of the advantages of it is it is going to have tungsten carbide on the tips, and I understand it's also going to be clad on the flanks. So that will be an interesting comparison, given that it is a Bundaberg Walker's Material B roll compared with our Racecourse number 5 top roll, which is an SG iron roll. So where we're at, the first real milestone, milestone 2, covers the baseline evaluation. It's due on the 1st of April, and we're working as hard as we can to meet that milestone. And then we have the following milestone, which covers the preparation of the Racecourse number 5 top roll. And our objective, of course, is to get that roll into service this year. And it's also to do some measurements, not just of diameter, but also of the groove profile of each of these 4 rolls, so that we've got something to compare against at the end of the season. And that milestone's due on the 1st of August. So just a few extra acknowledgements. I couldn't fit everyone onto the co-author list. From Mackay Sugar, Marty Iten now has done a brilliant job in terms of organising our our cladding facility. As you saw in the photo earlier, it's pretty much all set up and ready to go. Magella Daly is the HSE coordinator here, who's had a fair input into preparations for the work we're doing. The CSIRO team, Tony Kilpatrick, Con Philippou and Hans Law, have been up here preparing for the laser cladding. Unfortunately, we didn't quite get to the point of utilising them. And Dale Johansson from SWP, who'll be doing the tungsten carbide and MIG welding for this season. And also a big thank you to Glenn O'Malley from Wilmar, who organised the interview process at Pioneer last week. And of course the funding for the project from Sugar Research Australia. Thanks very much.
Thanks, Geoff. Okay, so as we've mentioned before, just put any of your questions down in Q&A. I do have a question here for Ehsan, if you could unmute yourself again.
Sure.
Is the feed roller nip dimension a variable to be investigated? Is the feed roller nip dimension influenced by the billet sizes? Given the variability coming from harvesting, does this potentially lead to needing a variable feed roller nip?
Thanks for the question. I should say yes, the nip dimensions and the nip area is a parameter we're going to change, and that will be by changing the feeder roll setting. So the way we are going to do it is to bring two feeder rolls close to each other or far to change the feeder roll setting, and that will influence the nip of the feeder roll. And as the person who asked the question suggested, there has been a variation in billets that come to the mill for milling. And one thing that we are going to look at is to make recommendations on the best or optimal feed roll setting or nip dimensions for different billet dimensions, actually.
Yes, we do have I guess an expectation that the billet diameter is a parameter that should be considered in relation to the nip setting between the feeder rolls. We don't have any real evidence of that, but it is one of the things we're looking at. And if you look back at the test program that Ehsan presented earlier, he showed that the objective is to have the nip setting that we are testing adjusted on the basis of what the billet diameter is we're testing at the time.
Okay, thanks. I'm guessing all roll shells under trial have a 1.5 or 40 millimeter pitch times 35-degree grooving. Is that right?
Yes, that's correct. I think that's correct for most of them. I've got Steve McLaughlin from Racecourse here with me, so I might just push the camera around in his direction.
Yeah, number 5 top at Racecourse, it's a 38.1
The
millimetre.
microphone, please. Thank you.
How's that?
Better.
That through okay?
Yes, thank you.
Beauty. Yeah, it's a 38.1 millimetre pitch and 35-degree angle on the vessel groove pattern, tooth on centre for Racecourse number 5 top. And number 3 and number 4 are identical to that at Racecourse.
Thanks, Steve. And I understand that the number 5 top roll at Plain Creek is also 38 millimetres.
Okay. So keep the questions coming in if you'd like to ask a question. I'll just do a little wrap up now, but if any questions come in the meantime, I will cross back to them. So thank you for attending our first SRA Milling Regional Research Seminar. We hope that you found it of value and are keen to get feedback from you. After this session, you will receive a link to a survey that we'd like you to complete. It will only take a few minutes of your time and will allow us to improve our webinars in the future. Tomorrow, you will receive an email with the recording and the slides. Our next Milling Regional Research Seminar will be held on the 31st of March and will be presented by Dr. Darren Rackman on investigations to mitigate the effects of juice degradation in factory evaporators on sugar recovery and quality, corrosion and effluent organic loading. Our second presenter is Dr. Changrong Shai, who will present on assessment of microbial degradation in factory mixed juice and filtrate. Please go to the SRA webpage to see any of their other upcoming regional research seminar topics. And in tomorrow's email that you will receive, there's also a link to the invitation for these webinars, which will allow you to register and click on the links for the upcoming sessions. So at this stage, that's all our questions for today. So I'd like to thank our two presenters for your time, and just let me see, there's just something popped into the chat. No, that's just an admin issue. So thank you all for coming today, and we will hopefully see you on the 31st of March. Thank you.
Thanks, Sam, and thanks, everyone.
Thank you, Sarah. Thanks, everyone.